Okie dokie. In this problem, they tell us that we have a differential equation with these three equilibrium solutions, y equals 8, -9, and 1, and then they also give us a bunch more information about the y prime values for different y values. Now, how do we use this? My biggest recommendation is let's make a sketch of a graph, because visuals will totally help us identify which of these statements are true. So we will start with the equilibrium solutions. So at y equals 8, -9, and 1, we are going to put our equilibrium solutions, which we know at this point look like little dashed lines representing the zero slopes, or the y prime values of 0 on our slope fields. So starting with that, we then move on to this information, and we're going to display this information somehow on this graph. How will we do that? Let's check it out. I need to extend this all the way to y equals 15. What do they tell us about y equals 15? They say y prime is 8. We don't have to draw exact slopes of 8, but we do need to draw lines that have positive slopes, because 8 is a positive number. So across 15, we have positive slopes, and we can sort of exaggerate them so that they're really showing that they're going away from the equilibrium solution of 8. And that's kind of a hint to the stable and unstable stuff. So let's keep going. Let's go to this one. Y prime is 7 when y is -15. So way down here, we'll do -15, and it is a positive slope of 7. So these lines are going towards -9. Let's go ahead and do these last two. At y equals 4, they have negative slopes, so these values are still going away from 8, but now towards +1. And then at y equals -4, we have a negative slope, or negative slopes. And now with all this information at hand, we can tell that 8 is unstable, because these lines are going away from 8 from left to right. And when we look at y equals 1, these lines are going towards y equals 1, which is solid, but then the lines below it are actually going away from it. So that means 1 is still unstable, because both above and below, the lines aren't approaching +1. So then when we look at -9, both the lines from above and from below are approaching -9 from left to right. So -9 is stable. With these labels, we can identify which statement is true. Let's see if we can sort these out here. So -9 is stable, 8 is unstable. Oh, that might be it. Okay, let's go through the other ones and eliminate them, hopefully. 8 is stable, that's false. So that makes the whole statement false. Both -9 and 8 are stable. No, because 8 is not stable. And then it says both are unstable. That's false, because one of them is stable. So it looks like A is our best answer. Let's go ahead and do 2 more examples for these. And we'll do it as fast as we can now that we know what we're doing. So equilibrium solutions at 9, 2, -9. So I'm just going to draw straight lines for these, speed up the process. At -8, that's just above -9, we have negative slopes. So negative, negative, negative. Just do 3 lines is all we need. Really, 1 line is all we need. At y equals 15, I'll just put 15 there. We have -1. 3 lines, negative slope. At y equals 4, we have positive slopes. And at y equals -10, we have positive slopes. Alrighty. Now, these lines are going towards 9, so we can say 9 is stable. Lines are clearly going away from 2, so this is unstable. And -9, these lines are approaching -9 from the left to the right, so that is stable. So let's see, so 9 is stable. So we have -9 is stable, 9 is unstable. That's false. 9 is stable. Good. And negative 9 unstable. Nope. Both negative 9 and 9 are stable. Yeah, that looks good. Break out the eraser to see that C is our answer. All right, one more real quick. Let's do -1, -6, 8. Do our straight lines to represent our equilibrium solutions where y prime equals 0. And then we find at y equals 0, we have negative slopes. Let's see if we can just do one big arrow. And then y equals -2, we will have a positive slope. At y equals 12, we have a negative slope. And -12, we have a positive slope. All right, lines going towards it, and the line below it, this line all the way down here, is going away from it. So because the one below 8 is going away, I was about to write stable, I mean unstable. This line is unstable, or this equilibrium solution is unstable because the line below it is going away from it, from left to right. So then at -1, these lines are definitely approaching -1, so this is stable for -1. And then from -6, above -6, this line is going away, so this is automatically unstable, even though the line below it is approaching it. So it looks like they say -6 is stable, false. They say 8 is stable, that's false. -6 and 8 are unstable, is what we're looking for, so not stable. So option D is our answer.